Good afternoon, everyone, and welcome to the Healthy Building Solutions webinar. My name is Kristen Vandeveer, and I'm with REAK Services. We're located in and service the Southwest Ohio region. Today's webinar is brought to you by REAK Services, as well as P1 Group Incorporated, servicing areas in Kansas, Missouri, and Nevada, and Vulcan Heating and Air Conditioning, servicing areas in Alabama and Tennessee. Today's webinar was developed by a peer group committee called Project Healthy Building, and that committee includes teams from REAK, P1, and Vulcan. And the primary objective of our committee is to provide solutions to combat the spread of COVID-19 and develop proactive strategies that we could all collectively implement to support and educate our customers about how to protect those people who occupy their buildings. So we're very fortunate to have three esteemed panelists who will be moderating today's webinar. First, we have Dr. Richard Jackson, MD, M.P.H. Dr. Jackson is Professor Emeritus at the Fielding School of Public Health at UCLA and previously the Director of the Center for Disease Control's National Center for Environmental Health. Dr. Jackson lectures and speaks on many issues, specifically those related to building environment and health. He has co-authored the books Urban Sprawl and Public Health, Making Healthy Places, and Designing Healthy Communities, for which he hosted a 4-hour PBS series. Our second moderator will be Ken Luchin. Ken is based in Kansas City, where he's the Marketing and Key Accounts Manager for ServPro. He has over 25 years in the commercial restoration industry, including biohazards, sewage, and commercial cleaning. He also has 7 years experience on the insurance side of the restoration industry. Our third moderator is Dean Saputa. Dean is managing partner of UV Resources, a leading manufacturer of UVC products for the HVAC industry that provides surface and airborne microbial control and organic materials decontamination. Mr. Saputa is an active member of ASHRAE, where he is actively involved in several committees. He was also a contributing author for ASHRAE's position document, Air Cleaning, that was published in January 2015. So thank you to our three panelists for joining us today. Now, following our panelists, we will be taking your questions, as Tony said, so please feel free to submit those using the chat box that's on your screen. When we get to the Q&A section of the webinar, we will also be joined by Tony Whited and Rusty Roderick, both Vice Presidents of P1 Group Incorporated, to support any technical questions that may be submitted. Now, if we run out of time and are unable to get to all of the questions, we will be sending out a follow-up email to everyone that's attending today, and we will direct you to our microsite with any follow-up answers. So with that, thank you all for joining us, and I will now turn it over to Dr. Richard Jackson.
It's a pleasure to be with you all, and my goodness, it's been a crazy month, hasn't it? I mean, pick up a newspaper from 6 weeks ago and it feels like 10 years ago. I'm a physician, pediatrician, ended up spending my career thinking about issues in the environment, and there I have some books and other things that I've done related to built environment, and I'll come back to that a little bit later on. After I did my pediatrics, I spent about 15 years with the California Health Department, learned a lot about pesticides, air pollution, childhood lead poisoning, a series of other issues, and was recruited to the Centers for Disease Control in Atlanta back in 1994, and was really looking forward to it. I became the head of one of the centers at CDC. It was called the National Center for Environmental Health. There I am being sworn in by subsequent Surgeon General David Satcher. And by the way, it was the oath of office that the president takes. And I thought I knew a lot about environmental health when I got there, and discovered that this center had about 500 people, had a laboratory that could measure parts per trillion in blood, urine, many other things, had a childhood lead poisoning program tracking around the country, air pollution, cancer clusters, birth defect clusters, radiation program looking at nuclear sites and destruction of the chemical weapons of the United States government, plus a bunch of international stuff. I didn't know when I first got there that one of the programs was the vessel sanitation program that inspected cruise ships. It probably came out of the fact that a dozen members of Congress got sick on a cruise ship a few years before and told CDC, we want you to inspect every ship that docks in the United States. And by the way, most ships are not flagged in the United States, so they visit the United States. By the way, they don't pay taxes in the US for that reason. And so we would send inspectors in to, check the water systems and the galleys, etc. But literally on the day I started work, I went back to my office. I got a call from CNN in Los Angeles, and a ship had docked in LA, and people had screaming diarrhea, if you will, bloody diarrhea, and there had been a death on board, and they wanted to know what we would do. And I had, of course, the inspectors go out and look at it, but we actually tied the ship to the dock, Coast Guard did, and had to have it completely scrubbed down. I subsequently learned that we were having dozens of outbreaks on ships every single year. And there were a whole series of problems. One is that the physical design of many of the galleys, of the restrooms, of the public congregating systems really did not make it easy for the crew to keep the sanitation levels up to where they ought to be. And over time, I moved us a bit away from inspecting the ships to actually being much more involved in the design of the ships, which is in some ways what got me into the whole business of architecture, urban design, as a way of upstream preventing disease. And that's really what public health ought to be doing, is the upstream prevention wherever we can. Once you've got 500 people with diarrhea, it's time to really, you have to get on site and help control that. But you can design systems that prevent cross-contamination, that assure that there's one-way airflow, et cetera. You're doing a lot more. One of the most common outbreaks, and this was a virus that I wasn't even taught about when I was in medical school, was something called the norovirus. And there were 8 outbreaks last year of norovirus, N-O-R-O virus, on cruise ships. And about 3 so far this year. You've heard about some of these. One was called the brown cruise because everybody on the ship, crew, passengers, and everybody else, had extreme vomiting and diarrhea. Norovirus is a RNA virus, and I know you're not interested in probably the virology, but in a way it's very relevant here. This brand new virus, the coronavirus, is a RNA virus. It's in the same family as norovirus. What's the significance? This new virus it's sort of an inside-out butter sandwich. The outside is a lipid, is butter, is oil, is fat. The inner side is protein, and the inside of it, on the inside, the capsid is RNA. What's the significance of that? So what? RNA, DNA. Well, this inside of it is a single strand of RNA, unlike DNA, which is in your cells and is very robust. DNA from 200,000 years ago can be extracted from bones and teeth from that far back, and they can actually almost construct the entire genome of that individual. RNA is a single strand. It's quite fragile, but it's very good at replicating. Just a point of science here, because it is important. I was confused because the labs would report how many cases of SARS-CoV-2 there are. And the issue here is the lab doesn't report diseases. The lab reports the identification of the virus. So you've heard about, we're going to reopen the system. We're going to get rid of some of the testing. We'll figure out what's going on. That's because we're looking for the RNA of the virus of people who are exposed. That's the test that they're doing, those long lines of people driving up and having swabs put up their nose. They're looking for the virus itself. What we're going to need to get out of this is an ability to look for antibodies against the virus, because then we know that people have been exposed and they should be more immune. But the correct name of the illness is COVID. And by the way, the 19 means that is first described in the year 2019. It's not that there were 18 prior viruses, no matter what certain people say. So COVID-19 is the disease, and we've been tracking it. And then I was on a radio show this morning. The numbers nationally are kind of, as you well know, astonishing. They're over 30,000, and where the death toll is increasing rapidly. So when I was in med school, I was taught that, the joke was, if the doctors are so smart, how come they can't cure the common cold? And one of the reasons was that it's a coronavirus. Most so-called colds are caused by coronaviruses. And this single strand of DNA is able, when it lands in your nose, in your nasopharynx, on the mucosa, even on your eye, it can get a hold of one of those cells and begin to replicate. It's extremely fast at replicating. This little strand of RNA, the simpler nucleic acid, can replicate to the point that one infected cell can put out 1 million baby viruses, we call them virions, from that. So, and it's also a sloppy process, if you will, of reproducing it. This one mutates all the time. So last year's virus may be slightly different from this year's, and it means your immunity from last year isn't as good. And the immunity to coronaviruses tends not to be as good as DNA viruses, for example. So that's one of the significant. So I've talked about neurovirus, or the brown cruse. You know that every year frankly, you should get a flu shot, because influenza changes from year to year. We usually make a vaccine that's a cocktail from several of the previous strains that have been going around. When I was young, I remember working in India on smallpox eradication, and we were worried about lots of diseases. Hepatitis A, used to be called infectious hepatitis, another RNA virus, was extremely prevalent. And oh man, you get hepatitis A, you're really sick. When I was growing up, polio was very common, and well, I'll just tell you a personal story. I was 3 years old when my fighter pilot father caught polio and died within 3 days. So these are very serious illnesses. Measles, oh yeah, it's childhood disease. A lot of these diseases in adults are terrible if you get them as an adult. SARS is the severe acute respiratory syndrome, and MERS is Middle Eastern, but these other three are often in the news. West Nile, again, an RNA virus. Zika, both of them spread by mosquitoes. Rabies spread by infected animals. And here's an odd line. New ones are discovered weekly. Not necessarily new human infections, but there are many veterinary infections that are RNA viruses. And that's one of the causes of this, is some of these viruses jump from one species to another. It's thought that it jumped from bats into the coronavirus in humans. There is some wondering about whether there may have escaped from a laboratory in China. We don't know that at this point. But and also plants have viruses, and a lot of them are RNA viruses. Tend not to they don't infect humans. But these things rapidly multiply, mutate quickly. They're highly contagious, and mostly they're spread from person to person. The thing you want least in the world is to get on an airplane and have the guy next to you sneezing the whole time. And I used to think it was kind of silly to wear masks on an airplane. I think from now on I will. In California, this is where I live, we're have been for the last 6 weeks, wear a mask and do social distancing. And with really good leadership from our governor, have been able to flatten the curve. We have about 1,600 deaths in the state, but this is considerably better than, for example, New York, which is only a third the size of California. You know the story about the Teddy Roosevelt, the aircraft carrier that's now docked in Guam, and there's 600 sailors who were infected. There's been 1 death so far. But the other point of this slide is that closed spaces, people very, very close to each other. Imagine how hard it is to take a ship. This is smaller than one of those cruise ships, by the way, but it has 4,000 to 5,000 sailors on it at any one time. and they are face-to-face. The bunks are triplex in a lot of these areas. Keeping this disinfected is going to be extremely difficult, and I'm sure the Navy's now giving a lot of thought to the air handling systems in these ships as well. The virus lands in the back of your nose, your nasopharynx, and that glistening mucosa, as we call it, begins to replicate quickly. If you have April allergies and you start sneezing, you may not even know you're sick. You may think it's your allergies, but if you're sneezing, the virus is already being dispersed around you to people you're close to. If you inhale it or it migrates down into your lungs, here's a picture, a CT scan of a 59-year-old who eventually died of it, but it basically destroys lung tissue, and we're later on learning it's affecting other tissues as well. Here's the case map for the United States, and you look at this and it looks like Southeast Ohio is home free, and Nevada looks pretty good as well, but I don't think anyone should take comfort that we don't need to worry about, because where we're living is not as lit up as some of these other places. It's a whole lot better to prevent this illness than try to recover from it. I think one of the big things we're worried about is our healthcare personnel overall. If you watch some of the evening news shows and you see what the nurses, the ICU techs, the emergency medicine folks, the docs, especially the emergency room docs, are dealing with, a pretty high death rate in those groups. This is very much present, and at the point of breaking, the hospitals in many of these places, I'm very worried when it hits the rural areas that we could, a lot of these have very low medical care to start with. Looks like if you're sick enough to be hospitalized, about 15% of the people die. So this is a very serious illness, and don't think that because 20 people die in a nursing home in New Jersey that it's going to spare all the young and healthy people. That's certainly not what happened with the 1918 epidemic, which was flu, not coronavirus. By the way, flu is not as contagious as coronavirus. It's sort of an ugly slide, but all basically that far right thing shows how coronavirus is now taken off and is the leading cause of death in the United States right now. And another piece of really kind of expected but disappointing news is that not only does coronavirus or this virus affect your lungs, but we're now seeing that it plugs up kidneys and people are needing dialysis, that they're left behind with heart abnormalities, again, probably circulatory in origin. And over time, we're going to learn many other complications, probably neurological, brain as well. So this is really serious. The point of this slide is that sometimes you think, well, if one little virus is on the tray table on my aircraft, that I might get this. I suppose it's possible, and the data isn't there yet, but it looks like the bigger the dose you get, the more likely you are to get sick. And if you get a really big dose, for example, doing a endotracheal intubation in this case, and imagine leaning over and trying to insert that endotracheal tube, you're getting a lot of exposure to viruses. And some of the people that were most soon affected were the emergency medicine and these folks. Now they're wearing proper, a lot more protective gear when it's become available. So here's the CDC guidance, and I recommend it to you about how to deal with this in independent living facilities. I won't go through it, but it's guidance about reducing public exposure in various facilities, to cancel events as well. I'm sorry about the dog barking. He tells me when there's somebody outside, and I don't need to know that right now. But this is the one, and it hasn't changed much. Clean and disinfect all common areas, common spaces daily. The list of things to clean, you on the line probably know all of them, but handrails, toilet handles, faucets, other places that we touch a lot. I picked up a brother recently at an airport, and he wanted to hand me his cell phone to have me look at pictures from his trip. I said, no, I'm not touching anybody else's cell phone, thank you. I was wearing gloves as well. Well, gloves are not as important as the masks, but they're still an important thing. Remember I talked about that lipid membrane on the outside of the virus? One thing that's important is it makes the virus much more susceptible to disinfectants. And here's the EPA list. It can be inactivated by almost every disinfectant that we have. And here's the EPA list of 370 disinfectants that work against the SARS-CoV-2 virus. So there's plenty of tools out there. I'm not an expert on this, and I defer to our later speakers. There's not much. I went to the AIA website to see what they were recommending. I think we're going to be thinking differently about the design of buildings. I suspect that automatic door openers are going to become much more standard. The public health school building here in Berkeley has positive airway pressure coming in. It's a new building, and it's heavily filtered air coming into the building, and so the air is exited out from the individual rooms. And Kaiser hospitals also have that same structure. So I think we're going to be moving to different ways of managing air handling systems as well. Particularly when you think about schools, and nursery schools can be a real hotbed of viruses. When we go see our 3-year-old granddaughter, I wear a mask, and she says, "Why do you have that on?" This is early in the epidemic. And I said, "Oh, I have the sniffles. I don't want you to catch it." But the real truth is, as every nursery school teacher knows, children are often the vectors because their immunity is lower than most people, and they're in such close contact with, no matter how good the parents try to be, the hygiene is always difficult with toddlers. So with this, I'm going to thank you for inviting me. I have, the good news is the disinfectants work, that social distancing works, the education has worked. I'm worried that we are not going to have a vaccine until well after the end of this year. I think there'll be some medications that will temper the severity of the illness. There's one from Gilead that's looking pretty good, but I'm afraid we're going to be dealing with this for the next year or so. And there are very big, difficult political decisions about moving out of the social distancing, and where do we go from here. So thank you for your attention. It's a pleasure to be with you all. Oh, closing. Wash your hands, self-quarantine, use a mask outside. I actually find the mask helpful because I wear glasses and I tend to touch my face too much. Wash your hands and take care of yourself. No one is having an easy time. With this, I'm going to turn it back over to the hosts, and it's a pleasure to be with you.
Good afternoon. Thank you, Dr. Jackson. My name is Ken Lujan. I'm the Key Accounts Manager and Marketing Manager for Serpro of Kansas City, and want to just touch base with you guys today in regards to what goes into doing a cleanup and cleaning procedures for the different protocols that have been written by the CDC. Along with the CDC, the RIA, which is the Restoration Industry Association, and the IICRC, the Institute of Inspection, Cleaning, and Restoration Certifications, are all putting guidelines out. The RIA and the IICRC have written a combined protocol for cleaning and that. And so the first slides that I'm going to be going to, we're going to talk about pre-work considerations when working with a cleaning company for the cleanup of the coronavirus or any other emerging pathogens. So the first thing a property manager, a building owner, a tenant, an occupant of a building should be concerned about is the health and safety of their occupants or their employees. You know, when we walk through and do an inspection, a health and safety inspection, a pre-site walkthrough, one of the things we're looking for is this a part of a building, an entire building? Is ventilation necessary? Is setting up other engineering controls, negative pressure necessary, depending on if they're still working in other areas of the building? And which protocol is most appropriate? Is it a preventative cleaning, a proactive cleaning? Is it a suspect or person under investigation type cleaning? Or is it a confirmed case cleaning? The next thing that we do in the on-site inspection, and why it's important to do that health and safety inspection, is identifying the proper PPE gear and requirements that are necessary for this type of work. Manufacturing is much different than office. While a lot of the personal protection equipment, like the respirator, the type of filters, the Tyvek suits, those type of things are going to be the same. You may be required to wear a hard hat, additional eye protection, steel-toed shoes, those type of things to be compliant with working in a manufactured area. Hazard communication after that site inspection to all tenants, occupants, employees, and then our staff is very important to make sure that we're following all guidelines necessary for that specific work site environment. And then another area would be to look at the possible engagement of an indoor environmental professional or an industrial hygienist to come in and potentially write a protocol based on maybe a confirmed person in a very large facility that would not require the full cleaning of the entire facility. However, there are people within the organization that feel that it might require that. So bringing in a third party can be very beneficial in this case to make sure that a protocol is written to site-specific standards to include what areas need to be done under the top cleaning method is confirmed. Is there areas that we need to go beyond that to make sure that the site is safe for reoccupancy in other areas? What type of critical barriers may need to be installed? Those type of things. And then on the back end of that, a clearance test and letter. The test is not any different than we would do on our own, and I'll explain what that looks like in a little bit. But you've got a third party outside of the owner, the property management company, the employer, and the cleaning company saying everything's good. So sometimes an industrial hygienist or indoor environmental professional may be necessary or wanted or desired by the customer. So what does a cleaning protocol look like? We'll get into each one of those in particular here, but you should expect to be given a written protocol and process that's to be followed on each one of these jobs to include the crew size and the time needed to complete the job. That's important so you can get back into business as normal after the fact. That's critical information that you're going to want to know to make sure that that's done in the timely manner that you need to continue to service your business. Loss of business or business interruption and any type of loss is one of the most drastic and hard things for a company. So being able to get that information very quickly from the person you hire to come in is a way for you to make arrangements for a very short period of time and then get back to work after that. And then what disinfectants are being used along with a copy of the safety data sheets is very important. And is it on the EPA approved list? And you're able to check that, like Dr. Jackson said, by going to the CDC to make sure that that's there. So a post-work evaluation and clearance needs to be done. I talked about that just a second ago. We do this through visual inspection. We visually inspect the areas to look for any debris left behind after the cleaning. The cleaning is supervised by a project manager as they're going through, so there should not be any debris left, but a visual cleaning through the process, and at the end of the process is done. And then we do a test clean, a representative clean of the area and the size of the project. So the larger the area, the more test cleans that we're going to do and towel checks. We're going to take a clean towel. We're going to put disinfectant on it. We're going to re-clean an area. If we see any yellowing or any residues left behind, that area needs to be cleaned again. So project documentation. Once the job is cleared and done, you should expect to get pre and post photos of the work site. You should have your written scope of work. You should have your pricing at the beginning of the job as well. And then a post-written recap of the job which would include the following. Was the protocol followed as it was described before? If not, why? What was the circumstances that you did not follow it completely through? What did the post-test inspection show? What, if any, additions or deletions were made from the scope? And if there was a hygienist involved, they would be doing the clearance testing in the exact same method as we would, as there's no other method at this time that I know of that the CDC has approved to do testing. And then you're going to have the ability to have a return of your occupants to your facility at that time. So the first cleaning process to help with this is actually a proactive cleaning method. This can be done with janitorial service that you have. It could be done with janitorial staff that you have, or you could bring in a third party such as ourselves to do this. And this is going around taking a clean towel that has disinfectant and cleaning doorknobs, light switches, countertops, bathrooms, keyboards, break rooms, those type of things, desks to include computer keyboards, phones, mice, file cabinets, hoods, those type of things throughout an office, same type of thing in an industrial or mechanical situation. This is something that can be done proactively every single day with staff. This can be done once a week. The CDC has guidelines that you guys can follow through this process as you do this. The web title, Preventing COVID-19 Spread in Communities, which addresses childcare facilities, K through 12 schools, colleges, universities, work environments, healthcare settings, large community events, and mass gatherings. Again, that document within the CDC website is Preventing COVID Spread, and it talks about the preventative cleaning in there, along with some of the items that Dr. Jackson talked about with the hand washing and the masks and those type of things as you go through. So the next step in the cleaning process would be a suspect or person under investigation. This builds on the proactive cleaning. So if you've been doing proactive cleaning and there is a suspect case that occurs, at that time, you're still going to need somebody to come in to follow the CDC guidelines, which would include doing the same protocol as the proactive cleaning. But on top of that, you're going to be also disinfecting, sanitizing soft goods, so office chairs, sofas potentially, any upholstered items, soft goods within the facility to include the carpet. So that is a real big difference between your proactive where there is nobody known to have come into the facility and you're just doing preventive cleaning and just really good housekeeping at that point, to now we've got somebody that's come through. We know that they've been in these areas. So we're doing a little bit deeper clean in these areas to make sure that we're taking care of everything we can. So we utilize a disinfectant fog during this process. So that helps with efficiency to get through the project quicker. And it does that by allowing us to disinfect large square footages at a time and then come back behind after it's had its proper dwell time. And that can be 2 to 5 minutes depending on the disinfectant that we use. And then we want a 10-minute dry dwell time after that. And then we can go back through and do our high touch clean and then our soft good clean with our cleaning towels that are, again, submerged in disinfectant, cleaning those desktops, those high touch areas. And then as that towel becomes soiled, it's discarded and a new towel is brought back into play. The next step is a known entity coming into an area, a confirmed person. And with that, the only difference between the first two protocols is we're now including cleaning the walls up to 8 feet within the structure. So each one of those sections does build on itself as you move through this. And the next thing that you're going to be seeing within the industry is a fog only that's being done around the country as a proactive or preventative cleaning method. Currently, that does not follow the CDC guidelines for proactive or suspect work or a confirmed case at this time as a standalone process. Again, we're utilizing the fogging protocol to distribute the disinfectant to make sure the disinfectant is getting everywhere and allowing that lipid, as Dr. Jackson talked about, to start deteriorating before our folks go in and start that cleaning process. It is important to continue to follow the CDC recommendations on their websites because they do change quite often. And that is our go-to every single day, first thing into the building as we move through this process to make sure that we're staying current with the guidelines. It is important to continue routine environmental cleaning. This routine cleaning with effective approved cleaning agents. Use the cleaning products in accordance with the labels directions. And then we talked about the fogging being used with all the disinfecting piece. With that, I will turn this over to Dean Saputo.
Thank you very much, Ken and Dr. Jackson. Very informative. Again, Dean Saputo with UV Resources. My portion here is talking about ultraviolet lights for infectious diseases and cooling coil applications. We've had UV lights being used in water treatment for the past 90 years. In upper air UV, which I'm going to kind of touch base on here in a few minutes, has been used for the last 70 years, mainly for the control of tuberculosis. And then probably in the last 30 to 40 years, it's been used in air handling units. And Dr. Jackson kind of mentioned that when he was talking about the ships and some regime changes for ships. And of course, same thing happens in buildings. One of the things we're getting a lot of calls on ourselves right now is when we're bringing employees back into a space, the employees are asking, what are you doing to protect me? What are you, the facility manager? What are you, the employer? What are you doing to protect me? So this could be one of the solutions. I think there's many solutions out there, and hopefully we can give you a little bit of guidelines on lights. So what you're seeing in this picture here, the picture is basically ultraviolet lights that are sitting on the back side of a cooling coil. And this is really just to bake out what's inside of the coil. They run 24/7, 365. All of the air that comes into from that building comes through the air handling unit. So if something is going to be airborne, it's going to come past these lights. Again, a cooling coil application is a little different than an on-the-fly application. So this has been standardized on for most hospitals right now for taking care of cooling coils. But we have to increase the number of intensity lamps to be able to kill something flying by in the air. The authority in our space is ASHRAE, American Society Heating, Refrigeration, Air Conditioning Engineers. They're the ones who, as a society, are writing standards, guidelines, recommendations. And one of the recommendations that they have out there is the ASHRAE Position Document on Airborne Infectious Diseases. It was written back in 2014, just was reaffirmed right when all of this stuff was starting to come out again. But in that ASHRAE position document, they're talking about what you should do in a facility to treat your engineering control strategies for airborne infectious diseases. What should you do? And they kind of bring it down to the categories, whether you're health, correctional, food, hotel, residence, and then they give you an application priority and then a research priority. So with your HVAC system, maybe dilution's the right thing for you. So bring in more outside air, help dilute that. Maybe temperature and humidity. And I think Tony Whitehead from P1 is going to talk about some dilution and stuff a little bit later on. But temperature and humidity, personalized ventilation. We're talking about masks. Wearing masks. Local exhaust. Try to exhaust more air outside of the contaminated air. Central system filtration, meaning increase your filtration. Local air filtration, maybe roll in the room type units. The other ones that we have on here is upper room UVGI, and UVGI means ultraviolet germicidal irradiance, or UVC, and then duct and air handling UVGI. It goes on to talk about in-room flow regimes and differential pressurization. Very high application priority for upper room UVGI. Again, we'll talk about that here in a minute, and then a medium application for in-duct. So when you look at the viruses, since we've been in water, ultraviolet lights have been in around water for 90 years and upper air for 70 years. There's been a lot of research done on the RNA, DNA type, as Dr. Jackson was saying, RNA. The amount of UVGI it takes, what we call a rate constant, to kill a certain product. So this is just the appendix from researchers showing when they were studied and how much it takes to kill something. So you can see there's been quite a few things that have been tested against ultraviolet lights and what amount of energy it takes to kill it. But obviously the ones we're talking about now are things like coronaviruses. So coronaviruses have been studied, MERS, SARS, they've been studied with how much energy it takes. You'll kind of see that over here. And then over here it'll say whether it was air or water. Water is going to be harder for UV to go through. But again, 90 years of expertise in water treatment UV lights have. We know how much energy it takes. So you can see the big difference here if you're going from an air side to a water side, the amount of energy it would take to kill something. So the researchers are saying, SARS coronavirus, what's the UV susceptibility and what should we be using for COVID-19? And right now, the COVID-19 has not been studied against ultraviolet light. However, the SARS, MERS, influenzas are very good basis for what you want to use as how to model and how much UV light you should be putting into a system. So if you look at the summary of all the different coronaviruses, they start out at a very small dose for coronavirus in general, but different strands of it here have different what we call kill rates. With an average of what we call 67 joules per meter squared to get 90% kill rate on it. We typically, when we're working with clients, we would rather pick the hardest one. Let's take the one that takes the most energy to be able to kill, so that as soon as we find out what the COVID-19 will do against UVC light, then we hope and we actually believe it's going to be less than this one here, but we'd rather choose the one that has the worst case scenario and model systems that give you that type of confidence level in. So when you're looking at HVAC applications, you're either going to be putting lights in and around a surface, as I kind of showed in that first picture. These are going to be, we use cooling coils a lot because it's the slowest moving air in and around an air handling unit. Not in the ductwork. Ductwork can work, but you're going to have to put more lamps in a duct because it's going by so much faster. But around the cooling coil and filters, that's going to be the slowest moving air in an air handling system. So we many times have a lot of room, at least by the cooling coils. One of the other big advantages of ultraviolet light from the very spectrum that comes off of this, the wavelength, it's 253.7 nanometers. That wavelength has a very high reflectivity off of surfaces that are made of aluminum. So what ends up happening is as that light is going in through the coil fins are made of aluminum. So you get a nice fluence of ultraviolet light that can be bathed inside of that coil. So as a microbe is coming by, it's getting hit multiple times because of reflectivity and because of the fluence. So back to the coil, if I'm doing a coil irradiation, again, this is usually used for coil cleanings, drain pan cleaning, and just keeping general maintenance of an air handling system. Well, that's about 7 to 10 watts per square foot. So 7 to 10 lamp watts per square foot. Trying to kill the hardest coronavirus, you're going to have to increase the number of lamps. And to do that, you're going to have to take your intensity up to about 30 plus watts per square foot. Now, what you're seeing in this picture here is a on-the-fly application that's at 500 feet per minute, 55 degrees. This particular one was a government job. I think I might have it on the next slide too, but we'll talk about that one in a minute. And then the next thing I'm going to talk to you about is upper air. So when you're looking at trying to kill something flying by in the air, you really want to have that lamp or that ultraviolet lamp be able to give a 360-degree distribution of energy so that as the microbe comes out and is in this space, that you're killing it as it's going towards the lamp and as it's going away from the lamp. So when you model kill rates, you're modeling off of this entire plenum because that lamp is giving a 360-degree distribution. As I mentioned earlier, in-duct on the fly, tighter spacing. This particular one here is, I'm going to go back, sorry, flipped ahead, is a job at Lackland Air Force Base, and there's 160 air handling units where this particular system was designed for a 99.98% first pass kill of tuberculosis, a harder microbe to kill than the coronavirus. So in this particular case, what you have is airflow coming from the left and airflow going up. So it has to take a 90-degree turn up. So this is many more lamps than what we would see, almost double the number of lamps that you would see for a coronavirus. Tuberculosis is harder to kill, but also we had to design this particular system of a microbe possibly coming out of the top of this coil and then turning up and going straight up. So a very short residence time. The microbe coming out of the bottom and gets to see all of these lamps had a longer exposure time. So always when designing systems, you're going to be looking at systems that are going to be for on-the-fly systems. What is the temperature? What is the flow? We want to design them at the end of the life of the lamp, highest flow rate, lowest temperature. So again, there was 1,500 lamps on that job, and that was the amount of energy was actually dictated by the military. They wanted to have a certain amount of watts in there, so quite a bit overkill. This is about 72 watts per square foot, where we're talking coronaviruses and influenzas around 30 watts per square foot. So you could take about half of those lamps out of that case there. So the other thing within the ASHRAE airborne infectious disease, as I mentioned earlier, they talk about upper air UV lights. We probably aren't as familiar with these as we are maybe with ultraviolet lights used in air handling units, but these particular fixtures are fixtures that have a lamp inside with, in our particular case, a parabolic reflector that is sending UV energy out through these baffles. Now, it's non-reflective baffles. It will not reflect that energy, so you're collimating a beam that comes out. Been using them around mainly patient rooms is where you'll see them, but we've been seeing them in daycare centers. We've been seeing them in lobbies, cafeterias, places like that, and I'll show you some pictures. But again, it's sending a collimated beam of UV disinfection up across the ceiling, and as the convection of the air in that room is going either from the supply to the return or just the pure convection of the air, it's going up into the kill zone. And I mentioned earlier, these are designed, at least the layouts are designed for tuberculosis, which is a much harder component to kill than what we're talking about in influenzas and coronaviruses. So they've been used since the 1950s for measles was the very first thing that they started use for, is in classrooms for measles. So again, we've had 70 years of proven data of how these type of fixtures work and what they can kill and what they can't kill. So just showing that there, I think, so we're talking about coronaviruses, and coronaviruses, yes, could be the world's largest killer of infectious disease, but right now it's tuberculosis. Right now, 1.5 million people die per year just from tuberculosis, and it's airborne. So that's one of the ways to catch it, and that's why fixtures have been used extensively throughout the world, fixtures such as this, for on the fly of tuberculosis. So where you usually will see them, they need to be a minimum of 8 feet up from on the wall. They'll send a UV energy across the ceiling. Again, that disinfection zone, it's not going down into the space, not where the people are. This particular picture that you see here is right above or right in the back of the return air. So the air that's flowing through that room is coming up through that return past the disinfection zone. This particular facility also has ultraviolet lights inside their air handling units too. So you can just see they're spaced out about, one of those units covers about 225 square feet. They can be in the room with the patient. It's above their head. So it's something that can be on all the time, 24/7, patient rooms. They could be in lobbies. You might see them in lobbies where you're just trying, especially hospitals, where they're trying to type people or people are coming in the emergency room, just trying to keep those disinfection or disinfect that air. You think about a hospital room has 6 air changes an hour, which means that every 10 minutes, that air is flushing out of that room and past these lights in through the air handling unit. And remember that air handling unit doesn't only service that patient room. It's going to service multiple patient rooms on that floor, unless it's an isolation room. But so these things can be used in that lobbies, for example. And then also here's a prep room. They just have them above the prep areas in this particular hospital. So just trying to knock down the infections that are happening there. And we've seen them also in cafes, school settings above common areas where you might have something, daycare centers. Before all of this had kind of broken loose in the last month or so, we'd seen a lot of these fixtures going into, believe it or not, doggy daycares. And doggy daycares were really because of kennel cough. And when they would take dogs out to play in a common area, they would line these up around the rooms to keep the kennel cough down from infecting the dogs. So certainly something to look at as possibly if you're a building owner or a facility, this may be something that gives that visualization to your employee or to customers that, hey, I'm doing something to protect you. This is again, as Dr. Jackson said, it could last till 2022. So I'm going to turn it back over to the moderators, and I want to thank everyone for attending and thank also Dr. Jackson and Ken for their informative presentations.
Thank you so much for your presentations, and we're going to have our question and answer section now. To our three presenters, we're going to add two more panelists, Tony Whitehead and Rusty Roderick. I have the first question here, and this question was asked during the presentation by Dr. Jackson, so he may be the person to answer this. Once you're exposed and have recovered from COVID-19, do the antibodies prevent you from contracting COVID-19 again?
Oh my, I hope they would. You know, with measles and chickenpox, varicella, your immunity is very strong after you get this. We're still trying to figure out how durable the immunity is with the coronavirus. And it looks like it's not going to be as good as it is with measles. I think you will have shorter term immunity. It will probably last a few years, but I think the jury's still out about how durable it is. The presence of antibodies is going to be very important as we think about restarting. We don't want someone going into a daycare center to take care of children and they're still susceptible. We would like to know that they have some kind of immunity on board, either from a vaccine or from having been infected in the past. So the jury's still out. I'm sorry, because we all want to, this is the big question and we all want to know.
Thank you so much, Doctor. We also have another question that probably is for you too. In the 2005 outbreak of the bird flu, the high fatality rate was linked to an out of control cytokine response. What is your opinion about cytokine storm being one of the major reasons for the severe reactions and fatality rate of this coronavirus?
Cytokines are an important part of our immune response. You have the T cells, then the, if you will, the gamma globulin, various kinds. But cytokine is a much more aggressive cascade of immunity. Back in the 1918 flu, it was found that young, strong, healthy people died at a very fast rate. The classic story from 1918 was of a healthy young man getting on the New York subway from Coney Island, and by the time he got to downtown Manhattan, he was dead from the flu. And that was just this cascade of immunity that fills the lungs up with fluid. We see that with hantavirus as well. And it's oftentimes viruses that have animal characteristics, if you will. Swine flu is probably what 1918 was. Hantaviruses from mice. But what we see is if individuals they're sick, they have muscle aches, they have a fever, it goes on for a few days, and suddenly you see a big spike in the temperature, in the fever, and that's when you really have to worry about this. The clinicians have tried anti-immunity drugs, they have tried steroids, which are anti-immunity. I think the jury's still out on that. For most of the time, it's what we call supportive care, enough oxygen, keeping the fluids, and sometimes you have to keep the heart pumping. But yes, it's true. Cytokine storm is something you worry about very much in these cases.
Thank you so much, Doctor. We have another question that was asked during Ken's presentation. Could you further explain what you mean by a disinfectant fog? What chemicals are being used to do that?
So the chemical is a EPA registered disinfectant. The disinfectant can be sprayed via a micromister. It can be sprayed with an airless sprayer. We have ULV foggers. So we just mist the disinfectant over the surfaces to apply the disinfectant to the surface. So the dwell time take place. So the dwell time on a surface is the amount of time that the manufacturer says that disinfectant needs to be in contact with the surface to disinfect it. And so it has a wet dwell time and then a dry dwell time. And then some chemicals have a residual, which means the residual can be effective for 30 days, 3 months, but none of that has been confirmed with COVID-19.
Another question for Ken. Looking for products for daily cleaning of vehicles, so many available products have higher toxicity, requiring ventilation, etc. Are there any recommendations for this?
You know, I've not personally done any vehicles, but the same products that we're using from a disinfectant standpoint, there is no residue left over after it has been used. So that CDC list of disinfectants would be an area that I would go to find that particular disinfectant that you should use. Food safety is another. Food safe disinfectants is also an issue, and each label will describe whether it can be used in confined space like a vehicle, kitchen areas, prep areas, those type of things as well within the labels.
Okay, thank you so much. When UV lights are put in an air handler with the air velocity at 500 FPM, how long does the air need to be in the UV light in order for it to be disinfected?
Great. Good. I cut off on me a little bit there, but basically, how long does it? So you would design everything in the UV light is based on time and intensity. So when you have little time to see the product, then you increase the intensity of the lamps. Kind of like that Lackland, what we saw was we had little time to see it, so the lamps had to increase. On a typical application where you may have, let's say, a meter downstream of a cooling coil, you're only seeing a product for about 0.39 of a second. So doesn't take long. It's going by pretty fast. So you have to increase the intensities. So those numbers that I had given were based on those 500 feet per minute, 55 degrees, end of lamp. So that was a good question.
This is Richard Jackson. Can I ask a question of Dean for a second on the UV?
Sure. Yes, please.
You know, when Americans hear the word radiation, we're very nervous, and yet we go out in the sun and try and get tan, but hopefully it's just UVA and a bit of UVB. Could you talk about, if you will, the hazards of UVC?
Absolutely. Definitely worth talking about. So if you notice in all of those, in the cases of an air handling unit, we're locked in. So we want to have door safety switches, light switches, signage to make sure somebody doesn't get exposed to the ultraviolet lights. The sun produces 4 wavelengths that in the ultraviolet spectrum produces UVA, B, C, and vacuum. And A, B, and vacuum can make it through the upper atmosphere, the ozone layer, but UVC can't get through the particles that are inside the upper atmosphere, so UVC gets rejected off. So when we talk about things that get down to the earth, to our levels, we're talking about UVA, UVB, and then the vacuum is more in your ozone, where ozone can be created. So in an air handling unit, exposure to a UV light would be detrimental to the skin and to the eyes. So always want to make sure somebody isn't in that space above that. You know, if you're in the upper air unit, definitely safety training for the maintenance people that don't get up there and change light bulbs with that unit on, must be turned off. Air handling units, no exposure. You just got to make sure that everything shuts off if anybody gets into that space. So very detrimental. It's very powerful, much more powerful than A and B, but not deep penetrating, and that's why it can't get through the atmosphere.
Thank you.
Yeah.
Oh, can we go to the next question? Apparently, yes, thank you. This is a very interesting question. Will COVID-19 and social distancing change how restrooms are designed?
We all ought to answer that one because I think we're all, if you will, guessing. I don't know if the average restaurant, for example, has UV across the ceiling. I think those days could be coming.
Yeah.
I honestly, if I were to go into a restaurant tomorrow, I would prefer that the server would, this sounds awful, but would be wearing a mask or would be documented as not, infected in the past and clear of the virus. I think we're still early in this, and we were saying, keep looking at the CDC guidance. I will tell you, I go on it every day. I study this. My son is at the CDC Emergency Command Center, and the information is changing constantly. So keep yourself tuned in. I've been giving the California government a hard time because their websites are not as useful as they should be. And honestly, the members of the public want to know how many people are sick in the nursing homes and what are the death rates or the illness rates. And having that information forthcoming, particularly in a state of 40 million people, is extremely difficult, or a country with 330 million. So this is the biggest event, honestly, in our lifetimes, and we're still learning as we go along.
Thank you. There's also a couple of questions from participants who want to know more about what we know. One question is about blood type. Would it make a difference what kind of blood type you have?
This is Dick Jackson. I've looked that up and haven't looked at it in about a week, but a week ago I had not heard that, and I looked for that. I have not seen that there's a difference with blood types, but realize when illness cases are being reported, they're going to report such and such an age, the race of the person that died, and where they lived, and what hospital they were in. But you would have to really do an in-depth study and go through a lot of medical records to pull out the blood types of, let's say, 500 deaths. I think that epidemiology is coming, but it's certainly not in front of us right now.
And the second question is that if we still think that this is not airborne, should we clean duct work after this is over?
Defer to Dean.
Sure, and I think there's been information out there. Again, tuberculosis, we have a great knowledge of how that gets spread, and airborne is one of the ways that it gets spread. So again, that's a harder product to kill than what we're talking about here in coronaviruses and influenzas. So I believe it's changing. If it does get into air handling systems, you might want to have prevention in there, and UV could be one of the things. Remember, ASHRAE's guidelines are talking about things that you need to do for air handling or for spaces. And also Tony Whitehead's on the line too that might be able to answer something like that too.
Yeah, I probably tag along with that, Dean. CDC, as an interim recommendation, is stating for employers to support their facility staff to increase room air exchange rates, and that plays in line there with the position document from ASHRAE that you brought up earlier, ventilation dilution. So that is a strategy that they're recommending for the interim, and who knows what the new norm will look like. Maybe that's a one-time. It is an interim solution. Maybe it ends up being something that's re-implemented on a case-by-case basis.
Yeah.
This is Dick Jackson. Quick question is related to this. Back when we were, thank you, Dean. When we were dealing with hantavirus, and the classic story was people cleaning out their summer cabins at the end of the winter, and there had been some mice in there and the rest, and they would be vacuuming, and we actually saw deaths of people because of the aerosolization of the hantavirus in these cabins. And we told people don't vacuum, use sort of a wet sweep, etc. But Is there any advice around this virus? It's fairly large, and I've read that it's good HEPA filters can stop it, but I don't know if I really believe that.
Well, that's a good point. On my previous life, I was a filter manufacturer, and a HEPA filter, and I can certainly let Tony Whitehead jump into this too, but a lot of those suggestions that you have to do with the ASHRAE document is you're going to have to change systems. If you're going to put a HEPA filter in, take out, let's say, a MERV 13 filter and put a MERV 16 filter in, there's got to be system changes to overcome that HEPA filter. So, you got expenses and new fans and other things that you're going to have to ramp up for. The other thing is a HEPA has is rated on a 0.3 micron particle. So a 0.11, which is kind of the virus size right now, Corona, SARS, influenza is in, that it still has about 20% of it that can get through a HEPA filter. It's smaller than what the HEPA filter is rated for. So it's a 0.3 micron for the HEPA filter, and they go 99.97 on 0.3, but a 0.11, it's only about 80% efficient.
Wow, thank you.
Yeah.
Thank you. Any additional comments on this subject? Dean, there's another question for you. Is there an issue of ozone production with the use of UVC devices?
That's a really good question, one that comes up a lot. So when this may take a minute, and I apologize, when you're manufacturing a lamp, like a Philips, a GE, an Osram lamp, the natural spectral line that comes off of vaporizing mercury is 253.7 and 185. And if maybe you remember, I talked about that anything below 200 nanometers creates ozone. So a natural glass would allow a 185 to come out of a lamp, and it would react with oxygen and create ozone. So you use that lamp in water. That's the water treatment lamp that you do. But when you're doing an air side application, the ones that I kind of went through here, you don't want any of the ozone coming out. Very bad. You don't want anybody breathing the ozone. So the manufacturers call what they either use a special glass or they dope the inside of the glass that doesn't allow anything below 200 nanometers to come out. So they are ozone-free lamps. So when you're looking at the ones I showed in the pictures, those are ozone-free lamps. I think there's a big confusion because there are lamps that make ozone used for water, but there are lamps, and there's all UVC lamps, but a lot of times they get intertwined. So no, for air side stuff, there's no ozone. They're non-ozone producing.
I'll just jump in quickly. There was a big flap years past about a disinfectant that was used on, for example, surgical equipment, ethylene oxide. And yes, in fact, it is a disinfectant, but it's really a sterilant. It's extremely powerful. It's not something you want around human beings. It cracks DNA. It's a pretty potent carcinogen. So, but I can understand how people say, oh, this vapor, but there are different vapors, and I defer to the engineers here about which one is the most toxic, but some of the sterilants can be really quite toxic.
Thank you. Any additional comments? Or there's another question here. What's the lamp life of the UV devices, and how do you know they're functioning since you can't see?
Yeah, so a lamp life by the manufacturers, which again would be your Philips, your Osram, your GE, and then the custom-made guys that make them too, they guarantee the lamp to be effective for 9,000 hours. So they also then, in a Philips, for example, says that I'll still have output up to 18,000 hours. So ASHRAE, when we wrote that in the ASHRAE handbook, about fundamentals of lamps, we just said it's recommended that you change the lamps out at the manufacturer's recommendation of 9,000 hours. They're going to be blue because it's just the argon gas that's inside of there. The argon gas is inside both a fluorescent lamp as well as a germicidal lamp, but that argon gas is just there to vaporize the mercury. So in a fluorescent lamp, the photon that is created by UVC stays in play, so the fluorescent lamp lasts like 5 years. In a germicidal lamp, because it's ultra high purity glass, it allows the photon to get out, and eventually after really maximum 2 years, you just don't have any UV left inside the envelope, but it's still going to be blue. So the quick answer to the question is 1 year per the manufacturers.
Thank you so much. So school districts across the country begin conversations about reentry in June or the fall, what do they need to take into consideration when preparing buildings? This will have a severe impact on our budgets, especially for daily cleanings.
This is Richard Jackson. I'm going to defer to Ken on this, but our governor just came out, California just came out 2-3 days ago with the parameters for when various kinds of reentry and startup will happen. And I think each of the states and localities are doing it differently, and they didn't have an absolute date. I think, this is me speaking, not anybody else, we are probably going to have different openings of different kinds of facilities over time, and they're going to be looking at much more of a case by case rather than just saying, okay, you can open up everything from the local corner store all the way up to the Super Bowl. And I think that trying to come up with a blanket answer on this one's going to be very, very difficult, but I defer to my other colleagues.
So we've been working with some school districts and some entertainment venues, and with that, they have decided to employ an industrial hygienist. In both of those cases, to write protocols for districts and entertainment venues with the companies that we've been talking to in the school districts. So having that third person party coming in, looking at each facility, looking at the different options of, is cleaning and disinfecting needed because the buildings have been vacant so long? Maybe, maybe not. Are portions of the building still occupied and those areas need to be addressed potentially? The UV lighting is a potential in that as well. So greater ventilation within the HVAC systems. Those type of things may all be part of that. Some conversation around doing temperature checks and those type of things, and some of the things they're doing in facilities and hospitals now as people come in may be part of that. I think there's too many unknowns at this point, what that looks like.
Thank you so much. Any additional comments? Some of our participants would like to know about the efficacy of electrostatic machines.
I would have to know what they might be looking for from electrostatic machines, whether it's electrostatic filters or bipolar ionizers or other things. If it's in the air side of it, I just really refer people back to what ASHRAE says. ASHRAE does have comments on different types of devices, and there are position documents, and there's another position document called filtration and air cleaning, which might be helpful because it does talk about different types of cleaning devices, so filters, UV lights, ozone. It's a free document also. It's available if you type in ASHRAE position documents. You'll see that there's a list of them. One's on Legionella and other things, but I think that might be a guideline to have you go look at the ASHRAE position document on filtration and air cleaning.
Ken had mentioned electrostatic disinfectants. I don't know if you want to supplement that one, Ken.
Yeah, sure. So with that, the electrostatic fog unto it by itself as a process is not recognized by the CDC as an approved protocol for any of the proactive, suspect, or confirmed cleaning processes this time. Now that may change once they get more information on the residual effects of those disinfectants and those type of things, but as of right now, it's not recognized.
Thank you. Any additional comments? Oh, another question here. With the CDC recommendation stating, if it has been more than 7 days since the person with suspected confirmed COVID-19 visited or used this facility, additional cleaning and disinfection is not necessary. As a building owner or property manager, what should I do since the guidelines continue to be a moving target?
So this is Ken again. I go back to industrial hygienist and the school districts and the entertainment facilities that we've been dealing with, that industrial hygienist becomes a good person to come in and give you a third-party review of your site-specific facility and what that protocol may look like for you individually, because every building could be different. They're set up differently with mechanicals, airflow, how tight the building is, those type of things. Is the building positively pressured, negatively pressured? There's a lot of variables there. They may come out that 7-day has changed. It was 3 in the beginning. I've seen it as high as 9. I've heard 17 days on textiles. So that's been a moving target. So the 7-day piece, I would still get a third-party evaluation on that.
Thank you so much. Any additional comments?
Richard Jackson, I think from a practical standpoint, and I understand the concerns about liability and having people go back in, and one of the things you learn as a young person is somebody can sue you for absolutely anything. So I understand why one needs to be defensive in this. I do want to say, however, that your big risk is being up close to someone and having those droplets and the spray hit you. That's sort of my point, and it's not proven yet. We don't know it yet, but I think the dose is going to turn out. The dose of viruses, the quantity of viruses you're exposed to, is important research that we're going to need very soon, because I think it predicts just how sick people are going to get, or if they get sick in the first place. We'll see.
Thank you so much. Our participants would like to know what governing bodies recommending optimization of ventilation and by how much.
Tony, you go ahead and take that one.
Sure. Ventilation requirements are established by ASHRAE. CDC refers to ASHRAE. And ASHRAE has a couple of different standards depending on the facility type. It could be normal, typical office buildings, schools, as mentioned earlier. They could be more specialized, like hospitals or industrial facilities. But there's a handful of standards referenced out there for minimum ventilation rates. And I want to emphasize that minimum. That standard establishes the minimum rates to promote health for the people in the building. There's nothing to say that you can't increase those rates, as CDC has recommended on the interim, to increase those air exchange rates. So they're the minimum, and on a case-by-case basis, should be considered to be increased. Circling back around to the question asked earlier about the school, what can I do to prepare? Ventilation dilution, increasing the outdoor air to that facility, could be a proactive measure to consider there. I think another important point on ventilation is there's a lot of facilities out there that have automated controls in place to reduce fresh air coming into the building. And that's kind of counterintuitive to what CDC is recommending for the interim. So, get with a qualified company and to help you out, identify if you do have those controls in place, and probably consider disabling them for the time being.
This is very important. I had not heard that before, Tony. Thank you.
Any additional comments on this question? Thank you so much. We don't have any other questions from our participants, so we'd like to know if our panelists and hosts would like to add any additional comments or make any suggestions to our participants today.
This is Richard Jackson. We're dying. We've got to get the tests. We've got to know who is susceptible, who's got the infection, and who is recovered. And there are many other pieces of information we need, but we've been flying blind for months now, and this is terrible. It's really tough going. And God bless those emergency responders and healthcare personnel on the intensive care units, because this is a tough haul. And psychologically, this has been, including the distancing and this isolation, this has been as hard an experience as almost wartime for a lot of Americans.
Yeah, Rusty Roderick. Just wanted to make one comment in summary, if you will, and that's you're right. These are some really tough times, and most of the folks involved in the call today are related to facilities, and so we just want to make folks aware of things that strategies and solutions that you can act on. And one of the things with Dean being involved and being a UVC light manufacturer, it's just important that folks start to act sooner than later. And the question hasn't come up, but how much does this stuff cost? And I think I'm not here to give you a cost, but I'm here to give you an order of magnitude. Is it $1, $10, or $1 million? And as an example, I think we would tell you traditionally a singular air handler, rooftop. Yep, they're all different, and the site conditions vary, but you're in the $5,000 to $12,000 range to put the UVC at this intensity level that's been recommended. And keep in mind, it's not for Corona 19, it's for Corona 20, 21, 22, for the next 20 years, right? It's the new world order that I think we're all going to be living within. So I think it's important to recognize that the cost of these solutions, it's all relative, I get it, but the cost of these solutions are not as astronomical as you might be concerned about. Again, an air handler, you're talking $5,000 to $10,000. The upper room UV, you're talking $1,500 to $3,000. And then the ventilation dilution that Tony spoke about, it's almost, if everything's working, it's almost very little. It's intellectual capital. It's understanding, don't create a new problem in the building, but it's not a large capital investment. So I just, personally, I'd like to leave everybody with that concept that these things really need to be acted on, because as soon as we do open the country back up, the new world order, I think everybody's going to want to invest in these, and the challenge is going to be no different than the N95 masks. The products are not going to be available. So any of you, again, that's why we want to be proactive with our customer base. Any of you that are thinking of being proactive, hopefully this conversation today helped you become more informed. So I just wanted to add that.
So Dean Saputo with UV Resources here, and Rusty, those are exactly the concerns we're getting. Is worldwide, the demand for ultraviolet lamps has quadrupled overnight. So plants are having to work overtime. They're trying to put new lines on. But I think what we're seeing from clients talking to us is maybe they're not running, they're getting the equipment, they're installing it, and maybe they're not running it, but they test it. They test it every month, make sure it works, so they're ready for the next one. We see so many people right now scrambling to get the lights in, and just lead times are going out and out and out. So what you had said was very true. Just if you're thinking about doing something like that, now's the time to plan it. Now's the time to get it in. It's just we predict the next 2 years just to be constantly backlogged.
I hope there's going to be cost savings if there's much greater production, because the school districts are going to be really hurting for money, and others are going to be putting this in. It's going to be a tough haul.
Unfortunately, we're running out of time, but if you had any questions that we didn't answer during the presentation, we're going to get in touch with you later and make sure that we answer your questions. We'd like to thank our panelists, Dean, Ken, Dr. Jackson, and of course Rusty and Tony for sharing their expertise with us today.
Thank you, Tony. Thank you, Kristen.
All right. It's been a pleasure. Thank you all.
Okay.
Thank you.
Okay, thanks.
Thank you.
Okay.